there! In our previous lessons, we talked about electromagnetic waves and its practical applications. In this video, we are going to discuss the effects of electromagnetic waves on living things and the environment. If you still haven't watched the previous lessons, you can pause this video and watch those first to better understand our lesson today. So let's get started! Radiation exists all around us, from both natural and man-made sources. It comes in two forms, ionizing and non-ionizing radiation. Ionizing radiation is a form of energy that acts by removing electrons from atoms and molecules of materials that include air, water, and living tissues. On the other hand, non-ionizing radiation is a form of low-energy radiation that does not have enough energy to remove an electron from an atom or molecule. Most types of non-ionizing radiation have not been found to cause cancer. The dividing line between non-ionizing and ionizing radiation occurs in the ultraviolet part of the electromagnetic spectrum. Radiation in the ultraviolet band and at lower energies is called non-ionizing radiation, while at the higher energies, to the right of the ultraviolet band, is called ionizing radiation. Ultraviolet radiation comes from the sun, welding, black lights, and UV lasers. The sun emits UVA, UVB, and UVC rays. UVC rays are absorbed by the ozone layer and never actually reach the Earth. Both UVA and UVB light are important for humans in the production of vitamin D. However, the effects of overexposure to ultraviolet rays can be negative and can be immediate or delayed. Sunburn, skin cancer, and cataracts develop over time with excessive exposure. The visible light portion of the electromagnetic spectrum can be seen by humans, animals, and other organisms. This type of light consists of 7 colors: red, orange, yellow, green, blue, indigo, and violet. When all the colors are present at one time, the light is white. Overexposure to visible light can damage both the eyes and skin. Infrared is used in thermal scanners, remote controls, and night vision goggles. The human eye can't see most of the infrared spectrum. About half of the total energy the sun gives off is in the form of infrared radiation, which we feel as heat. In large amounts, this type of radiation can damage the eyes and even cause blindness. Infrared radiation from the sun is normally absorbed by the Earth's surface and the clouds, then released as heat into the atmosphere. When the atmosphere has a lot of water vapor, along with nitrogen, sulfur, and fluorocarbons, the infrared radiation gets trapped and causes the atmospheric temperature to rise. This is called the greenhouse effect. Temperature increases cause changes in the weather patterns on Earth and lead to climate change. A microwave oven works because microwaves excite the water molecules in food and cause them to vibrate, generating heat and cooking the food. Atoms and molecules can also emit and absorb microwave radiation. Overexposure to microwave radiation can cause cataracts and skin burns. AM and FM radio broadcasts, Wi-Fi signals, cell phones, and television use radio frequency waves. Exposure to electromagnetic fields in this frequency range can warm up exposed parts of the body because these absorb the radio wave and convert these into heat. The frequency level determines the depth of penetration into the body. For example, using a cell phone causes the ear and/or head to get warm. Lasers aren't a form of non-ionizing radiation, but they are made from it. The word laser is an acronym for light amplification by stimulated emission of radiation. Lasers stimulate atoms and molecules and cause them to produce light and concentrate it into a beam of radiation. Lasers can be made from visible light, ultraviolet, and infrared waves. Store checkout scanners, laser pointers, and laser printers all use lasers. When not used properly, lasers burn and cause severe damage to our body, especially in the eye. The narrow beam of light concentrates the effects on the retina, causing blind spots. Ionizing radiation is a type of energy released by atoms in the form of electromagnetic waves or particles. Ionizing radiation takes a few forms: alpha, beta, and neutron particles, and gamma and X-rays. Ionizing radiation has many beneficial applications, including uses in medicine, industry, agriculture, and research. As the use of ionizing radiation increases, so does the potential for health hazards if not properly used or contained. Alpha radiation occurs when an atom undergoes radioactive decay, giving off a particle called an alpha particle. Alpha particles lack the energy to penetrate even the outer layer of skin, so exposure to the outside of the body is not a major concern. Inside the body, however, they can be very harmful. If alpha emitters are inhaled, swallowed, or get into the body through a cut, the alpha particles can damage sensitive living tissue. Beta radiation takes the form of either an electron or a positron, a particle with the size and mass of an electron, but with a positive charge, being emitted from an atom. It can be stopped by a thick piece of plastic or even a stack of paper. It can penetrate skin a few centimeters, posing somewhat of an external health risk. However, the main threat is still primarily from internal emission from ingested material. Gamma radiation, unlike alpha or beta, does not consist of any particles. Instead, it consists of a photon of energy being emitted from an unstable nucleus. Gamma waves can be stopped by a thick or dense enough layer of material, with high atomic number materials such as lead or depleted uranium being the most effective form of shielding. The extremely high energy of gamma rays allow them to penetrate just about anything. They can even pass through bones. This makes gamma rays very dangerous. They can destroy living cells, produce gene mutations, and cause cancer. Ironically, the deadly effects of gamma rays can be used to treat cancer. In this type of treatment, a medical device sends out focused gamma rays that target cancerous cells. The gamma rays kill the cells and destroy the cancer. The use of X-rays and radioactive materials in science, medicine, and industry led to the documentation of radiation burns. Radiation exposure, although helpful for the diagnosis and treatment of disease, might also be harmful, and protective measures were taken to limit exposure. All X-rays are dangerous because they can damage healthy living cells of the body. This is the reason why frequent exposure to X-rays should be avoided. X-rays can cause mutations in our DNA and therefore might lead to cancer later in life. For this reason, X-rays are classified as a carcinogen by the World Health Organization. While X-rays are linked to a slightly increased risk of cancer, there is an extremely low risk of short-term side effects. However, X-rays provide such a low dose of radiation that they are not believed to cause any immediate health problems. Lastly, neutron radiation consists of a free neutron, usually emitted as a result of spontaneous or induced nuclear fission. They can, however, be effectively stopped if blocked by a hydrogen-rich material, such as concrete or water. In living tissue, neutrons have a relatively high biological effectiveness and are roughly 10 times more dangerous at causing biological damage compared to gamma or beta radiation of equivalent energy exposure. These neutrons can either cause cells to change in their functionality or to completely stop replicating, causing damage to the body over time. Neutrons are particularly damaging to soft tissues, like the cornea of the eye. People are exposed to natural radiation sources, as well as man-made sources on a daily basis. Some basic information on protective measures can greatly reduce radiation exposure and risk for most people. What can a parent do to reduce the exposure of electromagnetic radiation? For example, children playing with electronic gadgets like mobile phones, laptops, and tablets are a common sight these days. The guiding principle of radiation safety is ALARA. ALARA stands for as low as reasonably achievable. This principle means that even if it is a small dose, if receiving that dose has no direct benefit, you should try to avoid it. To do this, you can use 3 basic protective measures in radiation safety: time, distance, and shielding. Time simply refers to the amount of time you spend near a radiation source. Minimize your time near a radiation source to only what it takes to get the job done. If you are in an area where radiation levels are elevated, complete your work as quickly as possible and then leave the area. There is no reason to spend more time around it than necessary. Imagine spending the day at the beach. If you stay in the sun the entire day, you will likely get sunburned. If you are there for just a short period of time, you are less likely to get sunburned. The amount of time you are there makes a difference. For toddlers, limit screen time by 1 hour of educational videos per day. You can reduce your exposure time by keeping voice calls short, especially when you are not using hands-free. Text instead of calling whenever possible. Distance refers to how close you are to a radiation source. Maximize your distance from a radiation source as much as you can. This is an easy way to protect yourself because distance and dose are inversely related. If you increase your distance, you decrease your dose. Imagine you are sitting very close to a fireplace. You can feel the heat and may even be uncomfortable. If you go to the other side of the room, you would be more comfortable. As you move away, the intensity of the heat decreases. When talking on your cell phone, your safest bet is speakerphone mode, with your phone a hand's length away. Not quite as good is using a wired headset. It still emits some radiation, but better than holding the phone to your head. A Bluetooth headset is your third choice. It will deliver lower levels of microwave radiation than your cell phone, but more than the wired headset. Turn your headset off when the phone is not in use. Try not to keep your phone turned on next to your body throughout the day. If you have a wireless router in your house or apartment, keep it in a little used room and out of the bedroom, or turn it off altogether at night. Strive to keep your bedroom as free of electronic radiation as possible. In addition to routers, turn off cell phones, wireless phones, and computers at night. Unplug electric devices near the bed. To shield yourself from a radiation source, you need to put something between you and the radiation source. The most effective shielding will depend on what kind of radiation the source is emitting. Some radionuclides emit more than one kind of radiation. Alpha particles can be shielded with something as thin as a sheet of paper or our outer layer of dead skin cells. Beta particles can be shielded effectively with a few inches of plastic or a layer of clothing. Gamma rays can be shielded effectively by adding a few inches of lead or other dense substance between you and the source of radiation. You may be tempted to use one of the many radiation shields on the market, but keep in mind that they may hamper reception, causing your cell phone to churn out more radiation. As what has been taught previously, keep away electronic devices in areas where people always stay, especially in the bedroom. In addition to time, distance, and shielding, let's include power and limit. Try to use your phone when you have the maximum number of bars, indicating the best reception. When signal quality is poor, your phone emits more radiation. Try not to use your cell phone in elevators, cars, trains, or planes. Cell phones draw more power and emit more radiation in enclosed metal spaces. Connect to the internet with an Ethernet cord, not a wireless router, whenever possible. When you are home, use a wired landline. Remember, cordless phones connected to a landline can emit radiation much like cell phones. Disable your device's wireless connectivity software, including Wi-Fi, Bluetooth, NFC, and the like. Otherwise, your device will continuously send out electronic handshakes, exposing you to more EMFs or electromagnetic frequencies. Lastly, use a wired-only printer, as well as wired computer peripherals like a mouse and a keyboard. Alright, here's a quick recap. Electromagnetic waves vary in their wavelengths and frequencies. Higher frequency waves have more energy. Of all electromagnetic waves, gamma rays have the shortest wavelengths and highest frequencies. Because of their very high frequencies, gamma rays have more energy than any other electromagnetic wave. Radiation exists all around us, from both natural and man-made sources, and comes in two forms: ionizing and non-ionizing radiation. Non-ionizing radiation is a type of low-energy radiation that does not have enough energy to remove an electron from an atom or molecule. Ionizing radiation is a form of energy that acts by removing electrons from atoms and molecules of materials that include air, water, and living tissues. Reducing electromagnetic radiation hazards follow the ALARA principle, which includes time, distance, and shielding. In addition, power and limit must be applied. That's all for now. We will be discussing about images formed by plane and curved mirrors and lenses in our next video, so stay tuned. See you in our next video, and don't forget to keep your minds busy. If you like this video, please subscribe to our channel and hit the notification icon for more videos like this.